Before we get going, I did want to introduce myself since I couldn't be there with everybody. And that's a big bummer. I wish that I could have attended in person, but I'm Ellyn Baines. I actually started with the chart array in graduate school. I used it for my graduate work, characterizing exoplanet host stars. So I was like super into the previous presentation. It's so much better than the stuff that I ever did with that. But I started observing with Chara back in 2005, it must have been, and it was a lot different back then. It was, there was the classic beam combiner and there was the first floor, and that was it. It was a lot easier to get time, let me tell you that. Basically go to Hal McAllister and say, hey, I need X number of nights. And he was like, cool, we'll make it work. And that was really nice. I miss that. And we had one observer. Do you guys remember PJ Goldfinger? She was there from Monday to Thursday. And so it meant that you were on your own on the weekends. And like that first Friday, I was going to figure out interferometry. I was going to be the person who got it on the first night. So what does everybody expect happens? 5 minutes into trying to observe, I call Nils on the phone, be like, I can't get light into the telescopes. He says, are your shutters open? I was like, okay, thank you, bye. At least I did remember to uncover the telescopes before I forgot to open the shutters. But after that, things went a lot better. Actually observed with Chara for a long time, quite a lot, both in California and remotely in Georgia. And it was really fun. But since then, since 2008, I've been at the Naval Research Lab. I work mostly, or these days exclusively, with NPOI data. I'll talk a little bit about the NPOI, since I think it might not be as familiar to some of you here, and some of the diameter work that we've been doing, as well as some of the recent 6-way data that we've been getting as well. Let me advance my slides somehow. Okay, so the NPOI stands for the Navy Precision Optical Interferometer. You see a picture of it there, sort of the center part of it. And it's located near Flagstaff, Arizona. It's actually quite beautiful out there. And it's a joint project between us at the Naval Research Lab, the Naval Research Observatory, and Lowell Observatory. And actually, Gerard Van Bell from Lowell will be giving a talk later this conference that I assume will be talking about sort of the current and future state of the NPOI. So he'll be giving you some more information on that stuff. But if you do have any questions about this, please send me a message. I'm always happy to talk about it. But the array consists of 10 siderostats, 6 of which are reconfigurable. We have these 3 sort of stationary stations, as it were. They're the astrometric huts. They never move. They're always there. And then we have 10 places on each of the 3 arms where we can put 6 other siderostats. So we can reconfigure it as needed. If we want to, if we need something, a nice tight configuration, we can think about that. If we need something with the longer baselines, we can think about that as well. And what's nice about these 2 kinds of stations is they're endlessly interchangeable. We don't have to do just the astrometrics in the center and just the imaging siderostats. We can combine it in any way we want. We get up to 6 beams at once. Our baselines now span about 16 to 100 meters. We always have plans to go to the longest baseline at 432 meters. And I'm determined to see it happen. We always want more resolution, and that would just be challenging because, finding a star that's small enough and bright enough to be interesting and in the right part of the sky, I'm talking to people who know about these problems, it will be challenging, but I think a lot of fun. We operate in the visible wavelengths. You can see the regime there. We take data in 16 channels, well, really 15, because one of them is a little too close to the laser and we can't use that data, but we get the rest of them. We have 3 beam combiners, 1 in regular use, 2 hopefully coming online pretty soon into more regular use. And we have 3 1-meter telescopes that are currently on the array. And I'm assuming that Gerard will talk a lot more about this, being integrated into the array and having larger telescopes, because our current siderostats are about 0.5 meter, of which we use the central 12 centimeters, but don't tell anybody. So having these 1-meter telescopes would be really exciting. So recently, sort of the most recent work that I've been doing are diameters, and they're not as sexy as some of the images that we've been seeing here, but I still think it's beautiful. We recently published diameters of 44 stars. We had a wide range of diameters from about 1 milliarc second to about 12 milliarc seconds. And what was cool about this is it had some new data, but it also, I sort of plundered the NPOI data archive, which went back to the 90s, and was able to publish some of the data. Like, if it's from 2005 and it's not been published, I sort of feel like it's fair game at that point. And I did talk to everybody, so I didn't cause any soap opera drama. But we got uncertainties of about 2% or less for all but 4 stars. So that was good, because 2% is, of course, what you like to not have the uncertainties balloon as you start to try to figure out stellar mass and densities and things like this for planets, especially. That's sort of that. I'm always thinking about exoplanets around these stars because that's where I got my start with interferometry. And we have mostly giants, but we got sort of the laundry list of parameters. We got the radius and the effective temperature after we did SED fits for the luminosity and volumetric flux. I'm speaking to people who know of these things. And here's sort of a representative image of some of the data from this paper. And the individual stars kind of don't even really matter. You can see the HD numbers in the upper right corner if you're interested in any specific one. But what I liked about showing this is you can see that we get a lot of data. And some of this is too much data. We don't need quite this much for some of these targets. But sometimes we can get the whole visibility curve. We can get up onto, and sometimes even beyond, that first null. And some of them, we don't, because life and stars are small, and interferometry is interferometry. So we do what we can. But you can kind of see there's just this flood of data that we get when we observe these guys. Okay, and this is going to be quite a short presentation, which I don't think anybody will be mad about at the end of the day. We have done 6-way data collection before, but it's one of those things where I hear people talk about it. And it's like, oh, we did that, right? But that was back in such and such. Oh, no, wait, there was with the other thing and and I'm not sure I ever heard a finalized year. I know it's been done before with the NPOI getting 6-way fringes, but 6-way data, but it's one of those things, it's like so much has changed since then, it almost feels fresh. So it's really nice to be able to get back to getting 6-way data with the NPOI. It's something that we worked very hard to do. So we got about 22 nights in the autumn last year of these, some of these stars. And you can see some of the baselines here, the baseline width range. And the way this E6 AC string, the A's are the astrometrics, those stationary huts that don't move in the center of the array. And E6 just means it's the sixth station out on the east arm. So W7 is the seventh station out on the west arm. And unfortunately, not all of our baseline combinations were recorded, because otherwise I'd probably still be trying to process the data. But that we have hopes that when we get our new beam combiners online, that we will be able to record those data as well. So here's some images. Here's some data that we got, and this is extremely lightly processed. And so you can see there's quite a spread in this. And I'm quite intrigued by that spread, especially for some of these stars. And I'll just tell you a little bit about some of these guys. So this upper left one, this is an interesting target because it's a HabX target. They're looking at it to see if it hosts planets, I suppose. And it's a possible binary. So we have a lot of data on this one. It was one of those situations where it was available, it was bright enough, and it was a good size. So we just observed the heck out of it because there was nothing else to observe. So we just really sat on this guy for a long time, which sort of made me happy. So this is about 1.2 milliarc seconds. We have Eta Aquila, which is a Cepheid. So this is only one night of data. And I'll just take this little box away for a second. And that's how much data we got, even not recording all the different baseline combinations. And we got almost 1,000 data points. So this will be high on my list of priorities. I'd love to go back to this star and observe this over time and see if we can detect those pulsations. We'd have to get that scattered down, of course, or at least be able to characterize it and know what's causing it, to be able to get diameter changes on that subtle of a scale. But I think it'd be really cool to try that. Up here, we have Epsilon Aquarius and Aquarii. What I like about this is a frequent NPOI calibrator. So if we can get a direct measurement of this, that's good for like future data collection. And this is actually quite small for the NPOI, 0.4 milliarc seconds. And you can maybe convince yourself that you see some dip in the visibility curve there. It's a little, I'd love to get something with slightly longer baselines if we can, to sort of nail down some of those higher frequencies. But I was really surprised and pleased that we got any sort of non-zero milliarc second measurement out of this. Down here in the lower left, we have another frequent NPOI calibrator, about 0.6 milliarc seconds. And I think that one is more convincing, that you can see the fall of the visibility curve over frequency. We have a double star here, Epsilon Pisces. I've seen Pisces and Pisces, I don't know. Anyway, about 1.8 milliarc seconds, but this is worth looking into as well. See if we can detect the binarity. And then over here, let me move my little thing. This is Omni Pisces, and this is about 1.6 milliarc seconds. So we have more to do with both these data, And also when we get back on Sky, the plan is to go back to 6-way and then reconfigure a little bit as well to demonstrate that we can reconfigure on a, not a rapid time scale, but a faster time scale than we have in the past. So yeah, that's it. That's what I've got to show today. Stay tuned for more from the NPOI.
Do we have any questions? Gail has a question there.
Hi, this is Gail Schaefer from the Chart Ray.
Oh, yeah.
Hi. Great to see all these visibility curves. So since this was 3-way or 6-way beam combination, do you get closure phases also? And did you inspect for any faint companions in these?
We have not yet. I'd like to. Something that happened that I think probably most people can relate to is both computers that we use to process data died at the same time. And it took a while to get all of our tools up and running again. So I had hoped to present a lot more on this at this meeting, but it's been about 2 months of trying to get things to work well enough to do anything. So we haven't done that yet, but it's definitely high on the list because why would you not? Yeah, why would you not, right?
So we have one question. So I see Gerard is in the chat, and we have questions in the chat. So what is the cause for the spread in the visibility data that is larger than the error bars? From Joseph Varga.
Oh, maybe I shouldn't have stopped sharing it. Well, that I don't know yet, and it's one of the things that I really would like to suss out. Is it something in the processing? Is it something in our data collection? Oh, sorry, I'm looking at Theo's comment there. So that I'd really like to know the source of that. Is it crosstalk? Is there some crosstalk going on that hasn't been characterized yet? I wouldn't say that these are beautiful diameters yet, but they sure are a lot of data. And maybe Gerard can have something to add to that if he wishes.
And there's a comment from Alex. So is there an online archive where the community can look for public data?
Not yet. Not yet. I would like to do that, but complications arise.
Okay.
So yeah, it's the short answer.
So let's thank Ellyn again.